Hi, I guess it's good afternoon to all of you. I'm currently in Singapore. My name is Aaron, so I'm with the Singapore team for Open Robotics, and I've been with the development for OpenRMF since the beginning, and I am currently leading the web team as well as working with all the other integrations that we have for OpenRMF. So I guess some people may have heard of OpenRMF before, and I'll just start off with a brief introduction of Open Robotics itself. So most people in the robotics field would actually know us to be the maintainers and the stewards of these large robotic software, which is ROS, ROS-II, and Gazebo as a simulation, and most recently, the releases that we have of OpenRMF. And for today's talk, this is mainly going to be focused just on OpenRMF, what it can do, what are the problems that we would like to solve with it, as well as what would come in the future for OpenRMF. And when we speak of robotics, we are currently at a point where we are seeing many amazing robots getting developed day after day, like with a lot of different functionalities. I think we have seen like plenty of delivery robots. It's very prevalent to have logistics robots in warehouses as well. Cleaning has become a pretty big thing, and then there's always the need for security as well. So with this many robots in a shared location, a facility, for example, in order for them to actually work well together, in a sense, interoperate, the optimal solution would actually to have all of them be able to communicate with each other and to actually share resources such that there wouldn't be any issues of deadlocks and all. Like for people who actually handle robots, I'm sure that you guys are familiar with the issues of running multiple robots. They don't talk to each other. So, but then we come to an issue where not all the robots are actually made from the same manufacturer, or they are from different fleets. They speak like in a sense where just like how we speak different languages, they use different APIs. They don't work well with each other at all. And therefore, it is actually becoming an issue for facilities who try to expand their robot capabilities, but have found that it is extremely difficult to actually get all of them to work together. But there has been a lot of resources spent on actually getting one fleet of robots to already work well in a facility, for example. And it has become rather difficult to further integrate or expand these sort of capabilities. And there's a lot of resources being used in these kind of cases. And most of the time we think that these sort of robots wouldn't really work together without like an extreme amount of effort on everybody's front. And this is where like OpenRMF comes in. Like we would like to solve this particular issue. And what is OpenRMF? So OpenRMF is a collection of libraries and tools, as well as simulation software that would enable us to actually resolve the issue that I just mentioned. And that is to allow robots from different vendors, robots from, or maybe even including like standalone robots that the facility themselves have built, to actually work with each other, get out of each other's way, interact with infrastructure and other systems that may be on site. And this is just a subset, a collection of the main components on what we consider the core libraries of OpenRMF. So I'll go into them like into detail a little bit more later. So as I mentioned, OpenRMF is a collection of libraries and tools for users or operators to actually interoperate between multiple fleets of robots. So the architecture, this is a brief diagram of how a deployment of OpenRMF can look like. And it involves the core libraries in the center, where we have the unified robot schedule, the traffic negotiation system, as well as the task management and dispatching system. And on our right, in order to allow different robots to communicate with OpenRMF, we employ something called the fleet adapter. So the fleet adapters are a piece of it's a piece of software which we allow operators or vendors to integrate as an endpoint to integrate their robot fleets and allow the robot fleets to work with all the other facilities as well as robot fleets currently in the deployment. So we have multiple fleets of robots, each running with their own fleet adapter. And at the same time, for infrastructure, we have doors and lifts, and they have their own subsequent device adapter that we may call as well. And we have our own suite of web software as well. So on the back end, we'll have the API server, and then on the other side, we can either run our already built, already developed minimal web dashboard for OpenRMF, or users can also implement their own UI to actually work with the API that we provide. And other than that, these are just like an example of it, but for the entire deployment of OpenRMF, there are also plenty of other API endpoints where users can actually implement their own either observation tools or interaction tools. So speaking of deployments itself, people have used a subset of the tools that I just listed just now to perform interoperability with all the different robots and facilities. And we have also, at least the one that we are more well known for, is our robot and deployment in the healthcare industry in Singapore. You would probably have seen, like if we looked a little bit online, we would find that maybe some folks have already deployed it in like multiple different locations. And because we're open source, we believe that there are much more locations and deployments than what's listed here that's out there. And yeah. So I would go into a little bit more detail on how we actually integrate these robots with OpenRMF. I think the key thing is to talk about the amount of control, or at least how do we actually get OpenRMF to work with the robots, or actually each fleet itself. So we understand that depending on the location, the type of robot, as well as the key performance indicators of that particular deployment of the robots, vendors might need to restrict how much information or how much control they can actually allow OpenRMF to have. So I will go from the top to the bottom. The most optimal API features that we would normally require from a vendor is what we will consider the path or the full control level of API features, where OpenRMF is allowed full control of the robots. We can redirect robots. We can make robots pause what they're doing. We can make robots move out of the way for other robots that are incoming as well. So that's what we consider the full amount of control. There is also slightly lower control than that. There is traffic light, where we are at least allowed to pause or resume the robots, but we can't actually reroute the robots, for example. And then further down, we have the read-only ones, where these are most of the time the fleet of robots where safety or how do I say, the key performance indicators of the deployment is really tied to, and the vendors or the operators at the site wouldn't really would not like OpenRMF to actually reroute the robots or to go anywhere else. So they would actually continue to perform what they have already been tasked to do, and all the other robot fleets would be managed to stay out of their way in that sense. And I guess one caveat is that for each OpenRMF deployment, there can only be one read-only, because otherwise, if there are two read-only fleet of robots, then OpenRMF cannot guarantee that collisions will not occur in this deployment. And last but not least, we have the fleet robot where the fleet API is not available at all. In that case, we will not be able to deploy it with OpenRMF as the main function of sharing resources like narrow corridors and doors and lifts is actually not able to be performed. So I guess it would be rather interesting for everyone to maybe think about or maybe like play around with OpenRMF. This is the GitHub repository that we have. It's OpenRMF, RMF demos, where we have a collection of simulation examples and demos for deployments of OpenRMF. This is a mock airport terminal that we set up with multiple fleets of robots. And on the left, when we see the green trajectories are where the robots intend to go. And when it flashes red, it knows, RMF figures out that there are scheduling conflicts ahead of time, and they would reroute the robots ahead of time to get out of each other's way. So this is one of the core resource sharing functions of OpenRMF that we see normally. The next one is the task allocation, so the smart task allocation. So OpenRMF, with each integration of the robot, OpenRMF has information of what each fleet of robot can do. So some robots can clean, but it's not able to deliver, while other robots can deliver. And what we mean by intelligent task planning is that users can insert into the deployment and request for a delivery task between two specific locations. And OpenRMF will figure out which fleet of robot is able to perform this task and will perform it the most efficient way. Maybe the robot is free at the moment. Maybe the robot is the nearest one near the particular waypoint and it needs to pick up the items. Or maybe the robot is the only one that has enough battery to actually perform this task. So now that I've mentioned battery, we also model the battery of the robots in OpenRMF to ensure that the robots are actually able to complete the task that we allocate for it. And depending on our configuration, you can also make robots hit back to the charger once they're done as well. Yep, so this one is one of the more interesting one as well. When we talk about resource allocation, other than making robots get out of each other's way, resources and infrastructure like doors and lifts are critical components of it. So we've come to a dilemma whenever a fleet of robots is integrated into a site, there would be necessary steps to take to actually get the robot fleet to work with the doors. And if we have n number of robot fleets, this would normally have to be done like n times. So what we try to solve with OpenRMF is that we integrate the facility infrastructure once, and they work with OpenRMF via the device adapters that I mentioned before. And all the robots that are then integrated with OpenRMF have access to these doors and lifts, and is actually able to share usages of lifts in this case. And in this GIF, we can see that there are actually 3 fleets of robots. One is coming up, one is going down, and then the other one will wait for its turn to go down as well. Another one that is not evident, it's not immediately intuitive is what we call automation systems, or in some cases, people call them Workcells. And this essentially is a term that we call systems where there's an interaction with the AMRs, AGVs, robots itself. And we also provide the interface for users and operators or engineers to develop the adapters for such a work cell, where they get to interact with OpenRMF and be part of the task allocation. Therefore, all the robots would also be able to interact with this. So in this GIF, this is an example where the robot would request. So the users requested a delivery of Milo can. So it's a local drink in Singapore. Yep. And then the robot would head to the work cell, and the robot arm, which is the work cell itself, would then be notified by OpenRMF to actually dispense it onto the robot. And then once it's done, it will tell OpenRMF that it's done, and then OpenRMF would send the robot on its way as well. So this is just one such example. Like most of the time we'd see work cells, it could be extremely sophisticated with multiple arms, multiple systems, or it could be an entire room as well. Yeah, so in terms of interoperability, we can't actually miss talking about what the standards are already out there. So OpenRMF is just the new kid on the block, I would say. So we have mass robotics interoperability standards, as well as the VDA 5050. And from what we know, to the extent that we know of, we serve very different purposes. The VDA 5050, as well as the mass robotics, like a reference, are highly catered towards the industrial standards and being a standards on how these robots communicate with each other. Whereas OpenRMF, other than performing that and having the standard messages and communications like set up within OpenRMF, we also provide the software packages and algorithms to actually perform these interactions and traffic scheduling and deconfliction on its own as well. So this is a vague roadmap of what we are planning to continue working with OpenRMF. It is by no means a solved problem. Like interoperability is extremely complicated. We are still looking into all the different use cases, as well as things that we can actually attempt to solve with OpenRMF. Users can actually see where our roadmap is on the ROS-I multi-robot book that we are hosting on our GitHub. Things that we are in progress right now, we are currently trying to figure out, and we are trying to develop multi-agent motion planning in free space, because we have found that a lot of the robots and vendors are actually requesting for this, and this would actually also make navigation much more efficient when they are controlled by OpenRMF. And there are like much more future opportunities that we can solve with OpenRMF as well, ranging from like further resource allocation, like making sure that everything is optimal when we interact with the robots, queuing of mobile robots when they are interacting with devices and such, getting very custom behaviors for the robots whenever tasks are allocated, and how tasks can be actually even more generalized than something like a delivery or a loop or a charging task, essentially. So these are all in the works for us. And of course, like we would all, when it comes to deployment, we'd also try to figure out like things like backing up and restoration in case of network connectivity issues and such. So these are all in the roadmaps, and we have documentation. Documentation is definitely a large part of our efforts, because we are open source and depends on our deployments out there. We have engaged with quite a number of folks, and we also would love to actually get more contributions or even suggestions from the community. These are some of the links that you can find the key components of RMF and where the demos are as well. So things are, it is built on ROS-I, We have the simulation framework using Gazebo as well. So folks that are already familiar with it, definitely check us out, build it, run it. We have binaries as well. So yep, we definitely look forward to seeing your questions and seeing what suggestions or contributions that the community can provide with us. And with that, I would actually end the overview and presentation of OpenRMF. Check us out on this website, and thank you all very much.